Okay, good day. Let us try to solve some problems uh, related to probability theory. So we will just focus on the items uh, that most of you did not really get the correct answer. No? So we will start with number 2. So we will start with number 2, letter C. Okay, in throwing 2 dice, what is the probability of getting, let's say, a sum of at least 10? So when you say at least 10, that is simply the same as when you greater than or equal to 10. So the possible combinations to have at least 10 will be these numbers. So we have 4 6, 5 5, and 6 4. For if you have, since greater than or equal to 10, you can also have 11. So if 11, 5 6, and 6 5. And if you have 12, we have 6 6. If we count them, we have a total of 1 2 3 4 5 6. So our answer will be 6 out of 36, which is equal to 1 over 6. Now, for letter D class, if both dice are even, so we know that in a dice we only have 3 even numbers, 2 4 and 6, so that we have 3 out of 6 in one dice. Since there are 2 dice, and we will have times 3 over 6, which is equal to 9 over 36, or equal to 1/4. And that is the answer. Okay, let's move now to number 3. Okay, number 3. In number 3, we are asked for letter A. We have a black king card. So we know that in a card, standard deck of cards, we have 52. And a black king is, we have 2 out of 52, or which is equal to 1 over 26. And this is for letter A. For letter B, a black card, we know that a black card is 26 out of 52. Or a king card, and a king, which is we have 4 out of 52. So we also know that there are 2 black king cards, so minus 2 out of 52. So what we do here is we apply the addition rule. So 26 plus 4, 30, minus 2, we have 28 out of 52, or that is just simply the same as 7 out of 13. So that is the answer, 7 out of 13. Okay, now for letter C, so we have known for letter C, we have a face clover card. So letter C, we have a face clover card. So a face card that is Jack, King, and Queen. So that is 3. And that we have 3 clovers. We have Jack, Clover, Queen, Clover, King, Clover. So that is 3. The answer is 3 out of 52. For letter D, we have a letter card or a heart card. We have letter card, we have Jack, Queen, King, and Ace. And there are 4 types of 4 shapes. We have 4 times 4, we have 16. So we have 16 outcomes over 52 plus a heart card, and we know that a heart card is 13 out of 52 minus a heart card at the same letter card. So we have 4. So 4 out of 52. No? Ace hearts, King hearts, Queen hearts, Jack hearts. So that's 4. So 16 plus 13. What is that? We have 29 minus 4. We have 25 out of 52. So this is now the answer for number 3. Letter D. Okay. So we will proceed with number 4. Number 4, most of you did not get 4 letter B and 4 letter C. So if we have 10 standard size lottery balls and 3 blues, 5 whites, and 2 or reds are placed in a fishbowl, what is the probability of getting blue one and a red one when you are going to draw them simultaneously? So sabay. So for letter B, no? So the answer for letter B is that we are going to apply combination. We know that how many blues that we have? We have 3 blues. So we have 3 taken 1 times we have how many red ones that we have? A red one is we have 2 out of, so 2 taken 1 divided by, and we know that there are 10 balls, then we are going to take 2. So this is 3 times 2 all over what is 10 factorial. So that is 10 factorial over 10 minus 2 factorial times 2 factorial. So anyway, so we have 6 all over 10 times 9 times 8 factorial over 8 factorial times 2. This will be gone. So we have 6 over 10 over 2 is 5, or 6 over 45. Sorry, so we have 6 over 45. So 6 over 45 is just simply 2 out of 9. So this is now the answer. Oh no, sorry. Divided by 3. 2 over 15. Sorry. This is, should be 2 over 15. I'll just erase now. It's 2 over 15. Now, for letter C, so we are going to take them by succession. So succession. So the probability of non-white, we know that there are 5 whites, so therefore non-whites are 5. So at the first place, we can take 5 non-whites out of, no, sorry, we can take 5 whites all over 10 times, okay, now we have selected 1 non-white, so in the next ball we can only have 4 of them over, same, since 1 is already chosen, this will become 9. So the answer would be, okay, so this would be, okay, this is 1/2, and that would be 2 out of 9. You can take 2 out of 9 there. So that's how we solve for number 4. Now let's proceed with number 5. Number 5 is that if we are going to solve for number 5, we will just simply apply the multiplication rule. Since they are linearly independent, since they are independent rather, so since the probability of accepted in the schools, 3 schools are independent, then the probability that not being accepted in this school will be defined by 1 minus 0.3 times 1 minus 0.4 times 1 minus 0.5. So we can take 0.7 times 0.6 times 0.5, and we know that 0.6 and 0.5, it's 0.3, and 0.3 times 0.07 is 0.21. So the answer now here is 0.21. Okay, most of you got number 6 and number 7, only that for number 8. For number 8, letter D, you are asked that given that the student is a non-college student, what is the probability that he is unemployed? So we know for a conditional statement, probability given that unemployed given non-college, so this would be probability of we can say that is defined as probability of unemployed and college divided by, so what is the given? Non-college. So non-college. So this would be equal to, we know that the probability, we know refer to this table. So we know that unemployed as the same as non-college, we have 15 plus 7, so we have 22 out of 50 divided by non-college. If we count all of them, non-college, this is 15, this is 18, we have 33, we have 33 out of 50. Okay, so if we divide them, so we have 22 over 33, it's equal to 2/3, and this is now the answer. I guess that's it for exercises in probability.